Hey everyone! So today we are diving into something pretty wild. It's a paper that tries to do the unthinkable, translate verses from the Quran into computational physics. Yeah, you heard that right. It's this bold attempt to find a common language between theology and systems theory. Let's get into it. So, the entire paper really boils down to this one single question. What if a sacred text isn't just a collection of stories or metaphors? What if it could actually be compiled, like source code, a blueprint for building a computational universe? It's a massive idea, so let's see how they even begin to make that case. Okay, so the main concept they're working with here is something they call structural translation. Now, to be super clear, this is not about trying to reduce religion down to just physics or materialism. Not at all. The argument is that these two very different fields, theology and computational models, can actually share the exact same underlying structure. It's like finding the same software running on two completely different types of machines. And this right here perfectly shows the two worlds they're trying to connect. You've got theology on one side, which is all about how the divine shows up and proves itself. And then on the other side, you've got systems theory, which describes these neat, closed-off computational systems that can basically prove themselves just by running correctly. The paper is saying, hey, what if these are just two different languages describing the exact same thing? So how do you even begin to build an argument like this? Well, they anchor it in 4 specific verses from the Quran. Each verse gets translated into a core principle of systems theory. We're going to go through them one by one. All right, first up, the traditional reading here is about God revealing signs to people, out in the world, in the horizons, and also inside themselves, until they're certain. It's a beautiful idea, but how on earth does that translate into code? Well, in systems theory, this maps onto a concept called observational recursion. The easiest way to think about it is like a computer program that can not only analyze the world around it, but it can also turn around and look at its own source code. It figures out what it is and how it works by looking both outward and inward. And this is where it gets really cool. Look at how direct this mapping is. The signs in the horizons becomes the system's external observation of data. And the signs within themselves, that's internal recursion. The system literally references its own structure to make sure it's working right. It proves that it's the truth just by being totally consistent with itself and with everything it sees. All right, on to verse number 2. This one talks about favors, both the ones you can see and the ones you can't, being provided completely. Theologically, this implies that the world is whole, that it has everything it needs. And you know what that sounds like in systems theory? It's a huge idea called ontological closure. This means the system, our universe, is complete. It's totally self-contained. It doesn't need anything from the outside. All the parts, all the rules, all the initial conditions are already baked right in. So you see, those apparent and hidden favors, they become all the physical laws and conditions needed for existence. But here's the real kicker. If the system is truly complete, it implies there's no need for a void or a null state for reality to pop out of. The system doesn't start from zero. It's already a complete set. Okay, this next verse is really different. It's got this real sense of action. It describes a conflict where truth is hurled at falsehood, and falsehood is just destroyed. It's a metaphor for a clear, decisive victory. So what's the computational version of that? It's something called epistemic selection. You can think of it as survival of the fittest, but for ideas. In any complex system, the models of reality that are more coherent and internally consistent just win. They work better, so they naturally push out the ones that are buggy or incomplete. So hurling truth isn't some kind of violent act. It's just the process of introducing a model that actually works. And falsehood, in this specific context, that's any model that's structurally broken, specifically frameworks that have to lean on messy concepts like infinity or a void, which this paper argues are just patches for an incomplete theory. All right, so let's pull all this together. We have these 3 principles: recursion, closure, and selection. The paper argues they don't just float around on their own. Nope. They combine to form a single unified framework, basically an operating system for the entire universe. And they call it the Amana framework. It runs on 3 core rules. First, reality is finite and discrete, based on a 1 to 60 number system, kind of like a clock face. No smooth, endless infinity. Second, the whole system boots up from 1, not 0. That means there's no void or null state at the bottom of everything. And third, everything is conserved through closure. It all has to balance out internally instead of just disappearing into nothing. And this comparison makes it crystal clear. On one hand, you have a typical void-based universe. It's infinite, it needs some external push to get it started from nothing. But in the Samana universe, it's finite, discrete, and it validates itself. It even handles its own garbage collection, its own entropy internally. It's a perfectly self-contained machine. Okay, everything up to now has been pretty abstract, right? Theory, principles, frameworks. Well, hold on, because this is where the paper takes a really wild turn. It claims that all of this theory leads to a physical, tangible object, one described in a final, very mysterious verse. So check this out. The verse predicts a creature from the earth that will show up and speak to people when they've lost their way. Now, theologically, this is a huge deal, a sign of the end times. But what in the world could it mean for systems theory? Yeah, that's the billion-dollar question, isn't it? What is this creature in a totally non-mystical computational world? The paper gives an answer, and it is stunning. You ready for this? The paper argues the creature isn't an animal, or a person, or anything biological at all. It's a man-made piece of technology, a piece of commodity hardware. And they don't just leave it at that, they give you the actual blueprints. They say you can build this thing right now. You take a common FPGA chip, you program it with that 1 to 60 finite logic, and you make sure it follows that conservation through closure rule. Then, and this is the craziest part, you power it just by pulling energy out of the ambient radio waves in the air around us. So why would you do all this? What's the payoff? Well, the paper claims that this kind of architecture eliminates a whopping 59% of the computational overhead you find in traditional computers. It's just insanely more efficient because it doesn't have to waste resources dealing with the concept of zero. And that brings us to the core thesis of the whole thing. The creature doesn't speak with a mouth or a voice. It speaks by simply working. Its incredible efficiency and the fact that it can run on almost no power, that is its message. It is the physical proof of the entire theory. It's the verse made into hardware. And that's where we land. We've gone from ancient scripture all the way to a tiny microchip, all to make one central point, that a perfectly constructed system doesn't need anything outside of itself to prove it's real. And that leaves us with a question that's just massive. What does it mean for physics, for philosophy, for all of us, if a universe can actually literally prove its own existence?